Welcome to part 2 of factoring a difference of two squares. These problems are a little bit more difficult than the problems that were completed in part 1. So if you're watching this video, you're in Algebra 2 or above, maybe in Accelerated Algebra 1, but the difference of two squares we're going to solve from here are the next level up. So we want to factor 16x squared minus 100. First, I notice everything is a perfect square. 16 is a perfect square, x squared is a perfect square, and 100 is a perfect square. So now I have to figure out, okay, is there a GCF? And in fact, both 16 and 100 are divisible by 4. Now you could factor this without factoring out the GCF first, and you can factor the GCF out at the end. I always check for a GCF before I start factoring any problem. So I'm going to factor out a 4, and I'm going to be left with 4x squared minus 25. After factoring out 4, I notice I'm still left with all perfect squares. 4 is a perfect square, x squared is a perfect square, 25 is a perfect square. Now I need to see what this looks like. 4 is the square of 2, and x squared is the square of x. So 4x squared is equivalently written as the quantity 2x squared minus 25 is the perfect square of 5. So now A is 2x and B is 5. So my expression factors into 2x minus 5 times 2x plus 5. Okay, now we're asked to factor 1 minus 81x squared. So I check. I have a binomial again. I'm subtracting. Now I want to check, is everything a perfect square? 1 is a perfect square. 81 is a perfect square. X squared is a perfect square. I don't have a GCF to factor out, so I'm going to go ahead and rewrite so I clearly know how to factor my difference of two squares. 1 is the perfect square of 1. 81x squared is the perfect square of 9x. So 1 squared minus the quantity 9x squared is equivalent to 1 minus 81x squared. So now I know A is 1 and B is 9x. So this is going to factor into 1 minus 9x times 1 plus 9x. Now, the more finesse you get in math, you will know we typically do not leave our terms out of order. So the x term should always come before the number. So I'm going to rearrange these. So this is negative 9x plus 1, and this one is 9x plus 1. And I'll say this in each video, we don't like when our leading term is negative. So typically what would happen is a negative 1 will be factored out of that first factor, which will leave 9x minus 1, because we factored a negative 1 out of everything in that factor, times 9x plus 1. And this trick is going to be very important, especially when you get to rational expressions, simplifying rational expressions, or solving rational equations. You're going to want to be able to rearrange that, factor out that negative 1, and write it in standard form so that you can complete the problem. Okay, let's factor 4x to the 4th minus 121. I notice everything is a perfect square, and as a note, any even exponent is a perfect square. So when I see x to the fourth or it's even, I know x to the fourth is a perfect square. This is a hint to keep in mind. Okay, so this, I don't have a GCF because 121 is not divisible by 4 or 2. So 4x to the fourth is 2x squared squared. And if you have difficulty seeing that, you're going to want to review the exponent rules video. You would see if I distribute that 2 into both of those factors, I'd end up back at 4x to the fourth minus 121 is 11 squared. So A is 2x squared and B is 11. So this factors into 2x squared minus 11, 2x squared plus 11. Double checking to make sure I'm done. 11 nor 2 are perfect squares, so this will not factor down again using difference of 2 squares, so we would stop right there. Factor 100 minus x to the 8th. 100 is a perfect square. We're subtracting. 8 is an even exponent, so it's also a perfect square. So let's rewrite. 100 is 10 squared minus x to the 8th is x to the 4th squared. Again, if you have trouble rewriting, you want to review the exponent rules video so you're okay rewriting x to the 8th as a perfect square. Okay, so that means A is 10 and B is x to the 4th. So this factors into 10 minus x to the 4th, 10 plus x to the 4th. Again, we don't like to leave things not in standard form. So negative x to the 4th plus 10, x to the 4th plus 10. We're going to factor out that negative 1 because we like things to look a certain way in math. X to the 4th minus 10, x to the 4th plus 10. When I see a subtraction sign with a binomial, I always make sure it's not another difference of 2 squares. 10 is not a perfect square, so we don't need to factor any further, and we are done. Okay, now we want to factor x to the 4th minus 81. X to the 4th is a perfect square because it's even. And if you've seen the pattern by now, it's always half. So the factor that was squared is always half of what the exponent was. So x squared squared minus 9 squared. So A is x squared and B is 9. So this factors to x squared minus 9, x squared plus 9. Always check. We have another difference of 2 squared. X squared is a perfect square and 9 is a perfect square. And because we've done this one already, I'm going to quickly factor it. It factors into x minus 3, x plus 3, and then times x squared plus 9. So this is your reminder to always make sure once you complete a difference of 2 squares, the factors that you end up with, you check to make sure whether or not they can be factored or not. Our last problem in the difference of 2 squares series involves 2 different variables. Now, when you're on the difference of 2 squares section in whatever course you're in, you will see two variables. Beyond that, when the difference of two squares comes up, usually it doesn't involve two variables, but you also want to be on the lookout for it because it is important. At 36x squared minus 81y squared, I know because I know my facts, 36 and 81 are both divisible by 9. So I know I have a GCF of 9 that I'm going to factor out first, which will leave me with 4x squared minus 9y squared. After I factored out my GCF, I see that both terms still are perfect squares. 4x squared is a perfect square. 9y squared is a perfect square. So let's rewrite. 4x squared is 2x squared minus 9y squared is the quantity 3y squared. So that means A is 2x and B is 3y. So this factors the 2x minus 3y times 2x plus 3y. And I double check. Both factors are prime. I cannot factor them any further. So I have completed factoring 36x squared minus 81y squared. I hope you have enjoyed the difference of two squares series, and I hope to see you in another video.